Okay, now we're going to look at example 3-9 out of Shigley, and of course my notes. And an awful lot of this work has been done for us in the example, but of course we could compute it ourselves if necessary. It says we have a shaft, we have two different pulleys on it. Pulleys transmitting power, quite likely from one place to the other. And we're going to want to figure out significant stresses in this part. So it's two 1.5 inch diameter. Oh, it's a 1.5 inch diameter solid steel shaft, simply supported by bearings at A and B. Okay, the pulleys are keyed to the shaft. Okay, where B is a diameter of 4 and C is a diameter of 8. Being keyed to the shaft means they transmit torque through the shaft. Consider bending and torsional stresses only. Determine the locations and magnitudes of the greatest tensile, compressive, and shear stresses in the shaft. Okay, and so given that's loading, recognizing being simply supported, we'll have an X and Y reaction at point A, and we'll have an X and Y reaction at the point that's labeled D. There is no axial or thrust loading because of these pulleys, and so we won't have to worry about absorbing any actual or thrust loading. There's no torque that reaches these bearings because the torque that comes in one shaft is taken out the other shaft. And so after quite a bit of statics, we see the 2-point reactions, the two reactions at bearing A, the two reactions at bearing D, and the load here has been added, these two forces added together into a single force and a torque in one direction. And then these two loads have been added together to give us a single load and a torque in the opposite direction of this torque canceling that torque or removing the torque. Now, drawing drawing shear and moment diagrams of this geometry. First of all, in the XY plane, where this 200-pound shear force will get us started. We move across. This load does nothing in this shear diagram. We move across to here, and that 600-pound load is applied, and then finally we have the 400-pound reaction in the vertical direction. And this is the loading diagram. It's not a shearing diagram, but from that loading diagram we can draw the moment diagram, and we transition from 0 up to a total moment of 4,000, and then dropping down to a moment of 0. In the other direction, we're going to have an 800-pound shearing load to get us started, and then the 1,200-pound at point B. This load does not come into this picture, but this 400 reaction does come into the picture here. And from this, we can also draw a moment diagram. We didn't draw a shear diagram, but shear would be a constant 800 in this region, minus 400 in this region, etc. I think you can picture the shear diagrams. Now, the question is, where are we most likely to fail? We are most likely to fail, I think, where we are at our worst moment, our total worst moment, our worst moment magnitude. Now, at point B, we have a moment of 8,000 in one direction, and at point B we have a moment of 2,090 degrees from there. The 8,000 combined with the 2,000 is probably worse than this 4,000 combined with that 4,000 at C. The 8 and 2 is probably worse, and so calculating that net moment by Pythagorizing the 8,000 at point B and the 2,000 at point B, coming up with an 8246 inch-pound moment, which is at some angle between the 8,000 direction and the 2,000 direction. And then in our shaft, perpendicular to this moment direction at the outer fibers, we would see max compression and max shear because of the, max compression, max tension because of these moments. Now, what about torsion? Torsion is going to be constant everywhere in here, and so our worst loading or our worst stress situation is almost certainly going to be at B, just to the right. So at pulley B, just to the right of pulley B, where we have some torsion going on, because just to the left of pulley B we would have no torsion. And what we would need to do is calculate the MC over I, calculate the TR over J, combine them in a Moore circle, and then make some decisions about either sizing or failure. None of that was done in this example. So in this example, we're just basically making arguments about where the worst situation was and why.